Okay, we're going to look at how you find the area of a region that's between two curves. So if I've got two curves, I've got the blue line here, which we'll call f of x, and the red line, which we'll call g of x. I want to know what the area of this region is. Okay, so let's take a look at how we come up with this. First, I could find the area under the blue curve. Okay, so if I want to know the area under the blue curve, it'd be all of this area underneath here, okay, between the blue line and the x-axis. And I would do that by taking, a bunch of little rectangles that represent, small areas and, add them all up, just like what the definition of an integral is. Okay, so we're going to kind of think about that to figure out how we're going to find the area of this region. So this is what one rectangle of the blue line would look like. Okay. Now, if I wanted the area of the red one at the same place, okay, that would be this. If you think about it, if I want the area of the inside part, I'm going to need to take the whole area under the blue and take away just the area under the red, and that leaves the area inside between the curves. Okay, so that's kind of what we're trying to do here. So really I want to use this rectangle. So let's look at what this rectangle would be. Well, the top of the rectangle, that's the value of the top function. Okay, that's the function f. This is f of x. The bottom value is g of x. So really, if I wanted to take a bunch of these rectangles, their height, this height here would be f of x minus g of x, right? Here, this value here is f of x, this value here is g of x. So its height is the top minus the bottom. And then its width would, of course, be our normal width, which is just our delta x, or dx in integral notation. So that means the area between two curves is the integral of the top curve minus the bottom curve, okay, because that's our height, times the width, or dx. Okay, so that's your general formula for area between two curves. Now, this is usually going to be a definite integral because they're going to give you some boundaries. Okay, maybe they want from point A to B. Okay, so you'd be going from A to B. Or maybe they want to know just the total area between the curves. So in that case, it'd be up to you to figure out where these curves are intersecting. And then that would become your A and B. Okay, so it depends on how they ask you to do this. So there's a few situations we need to look at. First of all, it doesn't matter where the x-axis is related to our curves. So if I move it down here, even if I've got one curve that's below, my rectangle still applies. Okay, my rectangle, find the area. I'd still take my value here and subtract the value here. Okay, even if they're both below, I'd still do the value of one minus the value of the other, because that's still going to tell me the height of my rectangle. Okay. The next thing we need to look at is, let's say we've got some curves that intersect in more than one place. Okay, if we have this kind of situation, we're going to have to find the 3 points where they intersect. Okay, now this one's changing because in this region, okay, my f of x is on the top. Okay, so for this region, I'm going to have the integral of the top function minus the bottom function from, okay, if this is a, this is b, and this is c, so I'd go from a to b. But for this next region, my g of x is on top, so that means I'm going to do the integral from b to c of the top function, which is now g of x, minus the bottom function, which is now f of x. Okay, so I'd actually do 2 integrals, one integral to find this area in between and one integral to find this area between, and then I'd add those 2 areas together to find the total area between the curves. Okay, so that's the basis of finding this. The other things that kind of come from this is how do we find these points where the functions intersect, and that's just solving a system of equations, which you can do with matrices or the substitution method or linear elimination. Just by setting the 2 equations equal to each other. So you'd say, when does f of x equal g of x? And then you'd solve that. And depending on what kind of functions these are, there'll be different methods for solving that. And we can review some of that in class. Okay, but this is the basis for section 7.1. So chapter 7, section 1. And this is beginning our chapter on applying integrals to different situations. So we'll get into some areas, some volumes, some physics problems, and things like that.